Priyadarshini from Physical Science Department from St. Ignatius Convent of Education. I am going to share about the topic periodic classification of elements. First, why we need periodic table? What is the need for it? Because to categorize the elements according to its properties, according to its elemental behavior, we need to classify those. Early atoms were made by Dobereiner, Newland, and Mendeleev, and we follow the modern periodic table because it is appropriate because it classifies based on atomic number. So we can see from the history of the categorizing the periodic table. Early atoms are classification. Before Mendeleev, scientists explored various ways to classify elements. Dobereiner's triads grouped elements with similar properties such as lithium, sodium, and potassium. Dobereiner triads, it is based on the atomic weight of 3 elements. It compares the 2 elements with the middle element. In Newland law octaves, it arranged in the increasing order of atomic weight. It repeat after the 8th element. Mendeleev's periodic table, it was arranged on 1869. Dmitri Mendeleev's arrangement of elements by atomic weight marked a significant advancement. This table predicted the existence and properties of undiscovered elements such as germanium, that is Eka silicon, gallium, and scandium, demonstrating the table's predictive power. Arrangement by atomic weight. Mendeleev had organized elements based on their atomic weight, grouping those with similar chemical properties together. Prediction of undiscovered elements. He left gaps for elements yet to be discovered and accurately predicted their properties based on the position of the table. Eka silicon predicted atomic mass 72, but it's actually 72.6. That is, it has the limitation because it predicted only based on atomic weight. So the gaps will be left, have been left in the spaces for which it occupies the another properties. Modern periodic table, atomic number. It classifies based on atomic number. In Mendeleev, it classifies based on atomic weight. But in modern periodic table, it follows categorizes the elements based on atomic number. Henry Moseley's discovery of atomic number in 1913 revolutionized the periodic table. Arranging elements by increasing atomic number resolved discrepancies in Mendeleev's table, such as placement of tellurium, iodine, and provided an accurate reflection of elemental properties. That is, Moseley's discovery of atomic number that is equal to protons has changed the conventional form of periodic table to identify the clear properties of the element. Arrangement by atomic number resolve the inconsistencies in Mendeleev's periodic table. Next, the structure of periodic table of Mendeleev, the structure of periodic table based on Henry Moseley, that is modern periodic table, is based on periods and groups. The periodic table consists of periods, that is rows, and groups that are arranged in columns. Periods represent elements with the same number of electron shells, while group contain elements with a similar valence electron configuration and chemical properties. Periods. Rows n is equal to 1 to 7. Elements with the same number of electron shells. Groups, that is columns, elements with similar valence electron configuration and chemical properties. For example, alkali metals which are arranged in group 1, which have the same valence electron. Alkaline metals, that is group 2, which also have the same valence electron, that is 2, S2. And noble gases also, it has the same valence electron, that is inert gas configuration, noble gases. Next, metals, non-metals and metalloids. Elements are broadly classified as metals, non-metals and metalloids. Metals are typically conductive, malleable, ductile and lustrous, while non-metals are poor conductors and brittle, that is unable to break. The metals, while non-metals are haven't have the structures, exact structure, and metalloids exhibit intermediate properties and are often used as semiconductors. Metals, conductivity, malleability, ductility and lustrous. Non-metals, poor conductivity, brittle. Metalloids, in intermediate properties, that is semiconductors like silicon, germanium, which is used in transistors. Germanium first transistor was discovered and invented in 1947, Bell Labs. Blocks of periodic table, SPDF. These are the blocks which categorize the valence electron configurations. S block includes alkali and alkaline earth metals. The P block contains non-metals, metalloids and noble gases. The D block comprises transition metals, and F block consists of lanthanides and actinides. S block, that is group 1 and group 2, that is alkali and alkaline earth metals. P block, that is group 13 to 18, which includes non-metals, metalloids and noble gases. That is 18 inert gas configuration, noble gases. D block, transition metals, group 3 to 12, that has a variable oxidation state, catalytic properties. Example, iron catalyst in Haber-Bosch process. F block, lanthanides and actinides and radioactive elements. Periodic trends. Atomic radius, ionization, energy, electronegativity, which are the phenomenon changing according to the varying periodic table, from left to right or right to left. Periodic trends such as atomic radius, ionization energy, electronegativity exhibit predictable patterns across the periodic table. Atomic radius decreases across a period and increases down a group, while ionization energy and electronegativity increase across a period and decrease down a group. Atomic radius, that is, it decreases across a period and increases down a group. Ionization energy increase across a period, decreases down a group. Electronegativity increases across a period and decreases down a group. In Pauling scale, fluorine is most electronegative. Application of periodic table. The periodic table has numerous applications in chemistry and material science. It is used to predict chemical properties and reactivity, to design new materials, understand chemical bonding, and predict the products of chemical reactions. Predicting chemical properties and reactivity. designing new materials, that is alloys, semiconductors, understanding chemical bonding and compound formation. Periodic table, which served as a dynamic tool to evolve as new elements discovered or yet to be discovered, and to understand element properties. Ongoing research and refinement ensure that the periodic table remains a constantly evolving representation of our knowledge of the elements. Okay, thank you.